Ever had that moment where you're trying to explain to someone how to use like a really specific tool or gadget or something, but the instructions are just awful?
Oh, yeah, absolutely.
Like they make no sense.
Totally.
Well, that's kind of the puzzle we're wrestling with in AI right now.
Oh, okay.
How do we get large language models, LLMs as they're often called,
Uh,
to be able to master new tools, especially when those tools are very specialized and the documentation is, well, let's just say less than ideal.
yeah, it's a big challenge, and it's getting more and more important as LLMs become more capable.
Exactly. And you've actually brought some really intriguing research to the table today,
Yeah.
something called Play2Prompt.
Right.
So this Play2Prompt, it's a totally new framework, and it aims to help LLMs learn to use these specialized tools even when they're basically starting from scratch.
Yeah, think of it like an AI trying to figure out how to use a really complex machine, but the user manual is like missing pages and full of
Yeah,
typos.
exactly.
And yet somehow it manages to get the machine working.
That's a great analogy. So in our deep dive today, we're going to really dissect Play2Prompt.
Okay.
We want to understand not just what it can do, but the really clever mechanisms behind it.
Sounds good.
And this is super relevant for anyone who's following the latest in AI because it gets to the heart of how we can make LLMs more versatile and more useful in real-world scenarios.
Absolutely. This is cutting edge stuff.
Okay, so we'll start by sort of zeroing in on the main problem that Play2Prompt is designed to solve.
All right.
Then we'll break down its methodology step by step, and finally we'll really dig into those key innovations that make it so unique and exciting.
Sounds like a plan.
So let's start with the basics. What's the fundamental challenge when we're talking about LAMs and new tools?
Well, as LLMs are getting better and better, we're seeing more and more attempts to connect them with all sorts of external specialized tools, to do things that are beyond their inherent capabilities.
Right.
But the reality is that documenting these tools so that an AI can understand them isn't always easy or even possible.
Yeah, a lot of these tools are super specialized, maybe even custom built. So it's not like you can just pre-program the LLM with knowledge of every tool out there.
Exactly. Adaptability is key.
So what's the typical approach right now for getting LLMs to work with these new tools?
Right now, the main strategy, especially when we don't have specific training data for the tool, what we call a zero shot or few shot scenario, is to basically give the LLM the tool's documentation, along with maybe a few examples of how to use it right there in the prompt when it needs to use the tool.
Okay, so it's like giving the LLM a crash course on the tool just in time. But you mentioned limitations in a true zero-shot setting.
Yeah, exactly.
What are the main hurdles there?
Well, you have to imagine a user who's made a very specific tool for their own needs, but they might not be an AI expert.
Right.
The documentation they provide could be incomplete, inaccurate, or full of jargon that the LLM might misinterpret.
So it's like giving someone directions that are half in a language they don't understand.
Pretty much. And this can lead the LLM to make mistakes in the syntax when trying to use the tool.
Okay, so it's trying to use the tool but doesn't even know how to speak to it correctly.
Yeah, or even worse, it might completely misunderstand what the tool does and produce gibberish output, what we called hallucinations.
So garbage in, garbage out, basically.
Yeah.
But what about those example uses? Wouldn't showing the LLM how to use the tool be more effective than just describing it?
Absolutely. Good examples can be really helpful, but creating really effective examples isn't always simple.
Yeah, you need to understand the tool itself, but also how the LLM is likely to interpret the example.
Exactly. And the average user might not have that kind of expertise.
Right.
And while there are techniques to automate this prompt optimization, they often still require some initial examples, which we just don't have in a true zero-shot setting.
So it's like we need good instructions to get good results, but getting those instructions is the problem in the first place.
Yeah, it's a bit of a chicken and egg situation.
So how does Play2Prompt break out of this cycle?
What's really cool about Play2Prompt is that it moves away from relying on those external human-provided examples or perfect documentation.
Okay.
Instead, it lets the LLM agent actually interact with the tool directly.
So the AI is actually experimenting with the tool,
Exactly.
like a scientist in a lab trying different things to see what happens.
Precisely. And this is the heart of the tool play concept.
That's a great way to put it. So the first step of the Play2Prompt methodology is all about automatically generating these tool examples through this interactive process.
Right.
Let's dive into this tool play idea. How does the LLM even know where to begin if it has no prior knowledge of the tool?
It works by trying out different combinations of input parameters for the tool over and over again until it finds a combination that works.
Okay, so it's like trying different keys until you find the one that unlocks the door.
Yeah, exactly. And at first, it might not understand why a certain combination worked, just that it did.
Got it. It's figuring out what works before it figures out why.
And for each successful invocation, Play2Prompt does something really clever. It creates a plausible query that could have led to that specific tool call and output.
So it's working backwards, basically figuring out what question would have led to that answer.
Exactly. So it reverse engineers a complete tool use example with the query, the tool, the parameter put.
So instead of needing a human to provide those examples, the AI is discovering how to use the tool and then creating its own examples based on its experience.
Precisely. And this playing with the tool first is a key innovation because it lets Play2Prompt build up an understanding of how the tool actually behaves, what inputs it needs, and what outputs it produces, without relying completely on that potentially flawed initial documentation.
So it's like learning by doing. And how does it decide which parameters to try? Is it just randomly guessing?
Not quite. It uses something called a beam search framework.
Okay.
Imagine that AI has a few different ideas about what parameters might work.
All right.
Instead of picking one and hoping for the best, it tries out a small beam of these possibilities, simultaneously exploring multiple paths at the same time.
Okay.
It's like trying several keys at once to see which one.
Makes sense.
And at each step, it evaluates the outcomes and uses a process of self-reflection to guide its search.
So it's basically saying, did this work? If not, what went wrong and what should I try next?
Exactly. And this lets it explore the tool's functionality much more efficiently.
So we have this intelligent trial and error process leading to a collection of tool use examples.
Right.
What's the next step?
The second key step is where Play2Prompt refines the initial tool documentation.
So it's checking its understanding gained through this playtime against those original instructions.
Precisely, it uses beam search again to iteratively improve the documentation.
Okay.
It's like the LLM is looking at what worked and what didn't and saying, okay, the documentation said I need a parameter Y, but I was able to use the tool without it, so maybe the documentation is wrong.
So not only is it learning how to use the tool, it's also learning how to explain the tool better.
Exactly. And again, self-reflection is really important here.
Okay.
The LLM is trying to spot problems or inaccuracies in the documentation and then use that understanding to guide the optimization process, proposing changes to make it more accurate and complete.
So after these two phases, Play2Prompt has these self-generated examples and a refined version of the documentation.
Yeah.
How does it then use this improved knowledge to help the LLM actually use the tool effectively for a given task?
It takes the optimized documentation and a selection of the best tool use examples and puts them into the prompt that's given to the task-performing LLM when it needs to use the tool.
So it's like giving the LLM an updated user manual along with some clear demos.
Exactly.
Okay, that makes sense. So tool play leads to better examples and better documentation, which in turn makes the LLM better at using the tool in real-world scenarios.
Right.
Now let's get a bit more into the technical nitty-gritty.
Okay.
What are the core innovations that make Play2Prompt stand out from previous approaches?
All right, so let's break down the academic meat of this. The paper lays out this problem of having a task-performing LLM and a set of tools and this really tough zero-shot situation where the documentation might be bad and there are no task-specific examples to work with.
Right.
The main innovation is this iterative search framework where it's constantly generating and refining samples, whether it's those tool use examples or revisions to the documentation using beam search.
So it's a continuous cycle of self-improvement.
Exactly. And each cycle involves proposing new samples, evaluating how good they are, using a reward function, and then keeping the best ones for the next cycle.
Okay, so it's learning and improving with each iteration. But how does the system actually decide if a generated example or a documentation change is good? What's the criteria?
That's where the reward function comes in, and it's different for the two stages.
Okay.
In the tool use example generation stage, the reverse order generation is a big departure from how things were done before.
Remind me how that works again.
Instead of trying to make a tool call based on potentially bad instructions, it first figures out what valid calls can be made and then builds examples around those successful invocations.
Right, so it's starting from a point of certainty rather than uncertainty.
Exactly. And the mechanism it uses to generate those valid calls is also innovative.
Okay.
It's not just blindly guessing parameter values, it's guided by the initial documentation and its own self-reflection to figure out what parameter combinations are likely to be valid.
So even when it's exploring, it's doing it in a smart way.
Right, and then there's the reward function for deciding how good a generated example is.
Okay.
There are two parts to this. The first part basically looks at the quality of the example itself.
So is the query clear and coherent? Does it logically lead to the tool use and the output?
Exactly, and this is actually judged by another LLM component, the example generator LLM itself.
So one LLM is generating the examples and another is judging them.
Yeah, it's pretty cool.
So it's being rewarded for creating good examples, but what's the second part of the reward?
The second part is where it gets really interesting. This part looks at how difficult or informative the example is.
Okay.
And it determines this by seeing how poorly the main task LLM does on the query when it only has the initial documentation and no extra examples.
Wait, it's rewarding examples that the LLM gets wrong.
Exactly, because the idea is that examples for things the LLM already does well, even with the bad documentation, aren't that useful for learning.
So it's focusing on the areas where the LLM is struggling.
Yeah, and the reward is actually the negative of the task LLM's performance, which means the harder the example, the higher the reward.
Okay, so it's incentivized to find the tricky cases.
Exactly, and that makes the learning process much more efficient.
Makes sense. It's like focusing on the weak spots to improve overall strength. Now, what about the innovation in refining the documentation itself?
In that stage, there's a specific LLM that generates the documentation, and it learns from the mistakes the task LLM makes when trying to use the tool with the current documentation.
So it's iteratively identifying weaknesses and trying to fix them.
Right, and the reward function for the documentation is based on how much the task LLM improves on those difficult examples that were generated in the first step when it uses the updated documentation.
So the better the documentation, the better the LLM performs on the tough examples it created itself. It's a really elegant feedback loop.
Yeah, and this back and forth between finding difficult cases and then improving the guidance to handle them is actually connected to active learning strategies,
Okay.
which basically means the system is actively choosing the data points that will lead to the biggest learning gains.
So it's learning how to learn, basically.
Exactly.
And how did this all perform in real-world testing?
They tested Play2Prompt on two well-known benchmarks, the BFCL executable subset and stable tool bench, which are designed to evaluate how well LLMs can interact with real-world tools.
And what were the results?
They were really impressive on the BFCL executable benchmark. There were significant improvements in accuracy for both LLMA and GPT models.
Okay.
The increases ranged from 5 to 7 percentage points for LLMA and GPT 3.5, and even 2.5 to 3.5 percentage points for GPT 4.0, which is already a very capable model.
So even a small percentage increase can be a big deal in the world of AI benchmarks, right?
Exactly. And what's really exciting is that Play2Prompt saw even bigger gains in the most challenging categories, like interacting with REST APIs and using multiple tools in parallel.
So it's not just doing well, it's excelling where it's hardest.
Right.
What about the results on Stable Tool Bench?
It was a similar story on Stable Tool Bench. Play2Prompt outperformed the baseline methods with average gains in the solvable pass rate of 5 to 7 percentage points for LLMA and GPT 3.5.
Okay.
And it actually beat the performance of EasyTool, which isn't a fully zero-shot method because it uses some labeled training data.
So Play2Prompt is achieving these gains without any handholding.
Right, and it was consistent across different parts of the Stable Tool Bench benchmark.
So it's robust and reliable.
And they also tested how well it handles bad documentation.
Right. I remember reading about that they intentionally made the tool documentation worse to see how Play2Prompt would cope.
Yeah, they removed parameter descriptions half the time, and even with that, Play2Prompt managed to prevent a big drop in performance.
Wow. So it's able to learn even when the information it's given is incomplete.
Exactly, and for GPT 3.5, it actually completely recovered from the performance drop caused by the bad documentation.
That's remarkable. So it can compensate for bad instructions.
Right, and they found that both the generated examples and the optimized documentation were important.
Okay.
When they removed either one, the performance wasn't as good as when both were used together.
So they work best as a team.
And focusing on those difficult examples was also really important.
Right. The AI is learning the most from the things it initially struggles with.
Exactly.
And what about the different search methods?
They compared beam search to other methods like Monte Carlo search, and beam search worked better for this particular problem.
So the way it systematically explores different possibilities is a key factor in its success.
And they highlighted the importance of self-reflection in both generating examples and refining documentation.
So the AI is not just blindly trying things, it's constantly evaluating its progress and adjusting its approach.
Right. It's like it's thinking about how it's thinking.
To make this concrete, was there an example in the paper where Play2Prompt actually found and fixed an error in the documentation?
Yeah, there was a case where the initial documentation had outdated parameter names.
Okay.
And through its tool play process, Play2Prompt kept running into errors when it tried to use those old names.
Right.
But by trying different combinations and observing what worked, it eventually figured out the correct parameter names and essentially corrected the documentation.
So it's not just learning to use the tool, it's actually improving the instructions for the tool.
Exactly.
Well, to wrap up, what are the big takeaway from this research?
The biggest thing is that Play2Prompt achieves effective tool use in a true zero-shot setting, meaning it needs no labeled data or human-made examples.
That's huge.
Yeah, it's a major step forward.
And this whole tool play paradigm is really innovative.
Yeah, it's a completely new way for LLMs to learn about tools by interacting with them directly.
And the way it simultaneously optimizes both documentation and examples using self-reflection is also a major contribution.
Absolutely. And the fact that it's task agnostic and scalable means it could be applied to many different tools and domains.
So it has the potential to be really impactful. So for you, our listener, the key message is that Play2Prompt is a big step forward in enabling AI to use new tools effectively in real-world scenarios where perfect instructions or prior training data don't exist.
And the tool play concept and this dual optimization strategy are really the key ideas here.
It's a clever way to bootstrap knowledge about tools without any human intervention.
The paper did mention some limitations, though.
Right, what were those?
The current version mainly focuses on single tool use, but many real-world tasks involve using multiple tools together.
Right, that makes sense.
And scaling this approach to tools with really large or complex parameter spaces might be tricky.
Okay.
And their current focus is on optimizing documentation and demonstrations.
So there's still room for future research to build on these foundations.
Definitely.
So as a final thought for you, our listener, think about the potential of this ability for AI to learn and optimize its tool usage on its own.
Yeah, it's a pretty profound idea.
What could this mean for different industries as AI becomes more autonomous and gaining new skills and knowledge just by interacting with its environment?
And what will be the next breakthroughs that allow AI to handle more complex multi-tool interactions seamlessly?
Lots to ponder. Thanks for joining us on this deep dive into Play2Prompt.
It was my pleasure.
If you're interested in exploring this further, we encourage you to read the full paper titled Play2Prompt, Zero-Shot LLM Tool Instruction Optimization via Tool Play.
There's a lot more detail in there.
And until next time, keep that curiosity alive.